Okay, broadband. Yesterday we talked about this unit circle quite a bit. And we're going to talk about it even more today. The distinguishing feature of it, of course, is that the radius is equal to 1. One of the viewpoints of the unit circle is we have whatever angle we're looking at here, theta. That radius, of course, is r, which equals 1. And it traces out that point on the arc of the circle. This length here is the sine of that angle. This length here is the cosine of that angle. If you remember back to last semester for our graphing, this point here on the circle then is a coordinate, an xy coordinate, where the x coordinate is the cosine of the angle and the y coordinate is the sine of that angle. We discussed yesterday what the angles do, or what the trig functions do as the angle gets bigger, at least as we go from 0 to 90. Remember, the standard functions, sine, tangent, and secant, get larger as the angle gets bigger from 0 to 90, and the cofunctions get smaller, cosine, cosecant, and cotangent, because the complementary angle is getting smaller as the standard angle, theta, is getting larger. We also related these to those triangles in there, and we found out that sine of theta was the opposite side over the hypotenuse. Cosine of theta is the adjacent length of the adjacent side over the hypotenuse. Tangent of theta is the length of the opposite side over the length of the adjacent side. Cotangent of theta is adjacent over opposite. Secant of theta is hypotenuse over adjacent, and cosecant of theta is the hypotenuse over the opposite side. And we looked at some of those relationships between those trig functions and how some of them are derived from the others. So we want to do a couple of things today. One of them is to calculate the value of a trig function for an angle using your calculator. So if I give you the angles, 30 degrees, and I ask you to find the sine of that angle, on your calculator, for the models that most of you guys have, you're just going to hit the sine key and type in 30. Hit equals, you should get 0.5. Anybody not get 0.5 when they type it in? Okay, that means you're probably in radian mode. 1/2? What calculator do you have? Here. Do you want me to take it out of math type mode for you? Hit the mode key and change it from math type to linear, I believe. Or classic, I think is what that one calls it. Okay. So if I want to find the cosine of 60 degrees, you're going to do the same thing. Hit the cosine key, type in 60. It should give us 0.5. Why would it make sense that those two are the same? What's the relationship between 60 degrees and 30 degrees? They add up to 90, right? They're complements. The sine of one is equal to the cosine of the other. The sine of the complement. So the cosine of 60 is equal to the sine of 30, which is its complement. Well, how about this one? How about we type in the tangent of 30 degrees? You get 0.577? Okay. So finding sine, cosine, and tangent of an angle are pretty simple to do. Let's look at our other functions. Secant of 30 degrees. Secant, if we look up here, is related to which one? Come on. Secant, remember, was the reciprocal of the cosine. So secant of 30 degrees is really 1 over cosine of 30 degrees. Now you could punch it into your calculator like this, but there is an easier way to enter it. You could always remember do 1 divided by cosine, which is fine, but your calculators have a key. Most of them have a key that's x negative 1. That is a reciprocal key. X negative 1 is the same as saying 1 divided by x. So what you can do is simply this. You do cosine. Most of your calculators give you an open parentheses. If they don't give you an open parentheses, we're going to have to adjust how you do this. Cosine, it gives you the open parentheses. Type in 30. You close the parentheses. Then you hit that x negative 1 key and hit equal. It should give you what? 1.15. Very good. So the secant of 30 degrees is 1.15. So using that same process, find the secant of 60 degrees for me. Did you get 2? Perfect. Cosecant is related to which of the other functions? It is the reciprocal of the sine, 1 over sine. Again, we could do just 1 divided by the sine of 30. Or we can do what we did up here. It's sine 30 degrees, close the parentheses, and hit the x negative 1 key. Tells us the cosecant of 30 is 2. I'm going to have you find, using that same process, the cosecant of 60. $1.15. Now you'll notice, by the way, the cosecant of 60 was equal to the secant of 30. Makes sense. It's a cofunction. It's the secant of the complement. Complement of 60 is 30. And the cosecant of 30 was equal to the secant of 60. Again, they're complements, so the secant of one equals the cosecant of the other. How about cotangent? Cotangent relates to what angle? Tangent. So if I ask you to find the cotangent of 30 degrees, that is the reciprocal of the tangent of 30 degrees. So you're going to enter the same thing. You do tangent 30 degrees, close the parentheses, and x negative 1, which will give you 1.732, 1.73, somewhere in there, right? So find for me the cotangent of 60 degrees. Get 0.577? Perfect. So we can find the value of the trig function from that. Well, we could also find the value of our trig function. I don't know why I drew out the unit circle. From a triangle. Let's say I have this angle here that I'm going to label angle theta. This can be thought of as being part of the unit circle, I suppose, if I wanted to, as extending outside of the unit circle, if you want to think of it that way. If I tell you, well, first of all, if I give you sides of this triangle, if I tell you that this side is 5 and that this side here is 10 inches, what is the sine of angle theta? Well, sine is opposite over hypotenuse, right? The 10's obviously the hypotenuse, The 5 is the opposite. So that's just 5 over 10, or 0.5. What if I give you, instead of those sides, I give you the angle here and I tell you that the sine of theta is 3 over 8, 3/8. Well, what that's telling me is this side over here is 3, the opposite side is 3, and the hypotenuse is 8. Can I find the third side? Yeah, if I label that a squared plus 3 squared equals 8 squared, correct? A squared plus 9 equals 64. Subtract 9. A squared is 55. And we square root. You get 7.42, we'll call it, is A. Well, now that we know A is 7.42 units long, I can find the cosine of theta, can I? Cosine of theta is adjacent over hypotenuse. 7.42 over 8. Tangent of theta is opposite. That's the 3 over adjacent, the 7.42. Does that make sense? So by using this idea of right triangles applied to that unit circle, if I know any of those 3 main trig functions, sine, cosine, or tangent, I can find the other 2. Also, I might tell you that here's my unit circle, and I have an angle that goes through the point up here. Oh, let's call that the point 7, 8. What does that tell me about this triangle? Well, it tells me if I draw in this triangle, what's the length of this side here? That's the y coordinate, right? That's 8. What's the length of this side? 7. So I know already that the tangent of that angle, whatever that angle is 8 over 7, or 1.142857143 approximately. Can I find the sine? Yeah, I sure can. I can find that hypotenuse. That hypotenuse is the square root of 7 squared plus 8 squared. A squared plus b squared equals c squared. Giving us 10.63. So the sine is which one over 10.63, the 8 or the 7? The opposite. The cosine, that would be the adjacent, the 7 over 10.63. What do you guys think? A lot of stuff to think about? The baby crying in the hallway? I'm going to give you guys a worksheet here. The side that you need to do is the side that's labeled page 345. There's another side on it as well that practices some of the stuff we did yesterday if you need more practice on it.